Okay, so welcome back to my channel, and in this video I will be talking about a very important topic regarding designing new drugs, that is ADMET, ADMET, or you can also call it as ADME. So ADMET is just an extension of ADME, where ADME is called as or it is an abbreviation of absorption, distribution, metabolism and excretion of the drug that we are trying to design or predict or work upon. So this is true. You can use this tool for all the molecules that you're working on. It may be a small molecule, it may be a drug, it may be a drug derivative, or it can be a phytochemical. So this implies to all the small molecules which we are trying to predict for the use of humans. And when we talk about the T at the last, it means the toxicity. So there are certain tools which we can use to predict the toxicity as well as different pharmacokinetics and pharmacological properties of the drug. Okay, so for this video what I will be doing is that I will be first of all downloading the molecule from PubChem, probably one of the well-known antibiotic, that is amoxicillin. So we will first download the amoxicillin from the PubChem. We will not download it, we will just copy the smiles. Then with the help of a Marvin sketch, we will predict or we will make its derivative. So then we will be having amoxicillin as well as its derivative. So once we have these two compounds, we will then compare the toxicity of these two compounds with the help of SwissADME, ProTox-II, which is another tool, admetSAR. Okay, and for designing the derivative of amoxicillin, we will be making the use of PubChem. Now, once you have created the derivative, if that derivative is it going to interact with some other molecules or other proteins of your body or not, you can also predict it with the tool which says SwissTargetPrediction. So these are the tools that we will be working in this tutorial. So first what we will do is that we will go to this PubChem. So as soon as we go to this PubChem, I will simply type amoxicillin. So we have this amoxicillin molecule over here, so we'll click over it, and then as I have mentioned earlier, what I will do is that I will copy its smiles. So I have copied its smiles, and onto the desktop I will create a notepad file. Sorry, just delete it. I will create a notepad file. You can also do the same, or if you don't want to do it, it's okay. So I will just paste the smiles. So these are the smiles of amoxicillin. Now once we have the smiles of amoxicillin, what we will do is that we will try to we will copy the smile. Okay, and then what we will do is that we will try to uh, make its derivative. So we will go to Marvin sketch. Okay, so this is the link where you can create the derivatives with the help of smiles. So first we will paste the smiles over here. So we'll just press on add. So now what Marvin sketch has done is that it has drawn the structure of amoxicillin. So onto this structure, as we want to just create the derivative, some random derivative, we will just create some modifications into this structure. Okay, so we will create a CH3 group over here, and onto this CH3 we'll add a fluorine. Onto this we can also add fluorine, and then over here I will what we can do is that we can okay, so this is the modified version of, say, an antibiotic that I have created just for the random explanation to you. So we will save the smiles of this structure. To save the smiles of this structure, what we will do is that we will just go to this icon which looks like this floppy disk. We'll click over it, and then into the format option you just copy the smiles, or you select the smiles, then you copy the smiles from this, and you can paste it into the notepad file, and here you just give it a name like amoxicillin derivative 1. So Amoxicillin D1 means the derivative of amoxicillin that we have randomly created. So the next step, what we want to do is that we want to understand that how these two drugs differ in their toxicity. Okay, so making any modifications into the drug makes it more toxic or less toxic. That is something that we want to study. We want to study what are the differences in the pharmacokinetics and pharmacological features of these two drugs or these two molecules. So for that, what we will do is that we can simply copy the entire file. Okay, and then we will use the first tool, which is SwissADME. So we have opened SwissADME, and then it says enter the list of smiles over here. So you just paste smiles over here. You just remove the first molecule, the name. Okay, just keep the smiles. Okay, so you have two smiles of two molecules over here, smile strings to be very precise, and then you simply click on run. What it is trying to do is that it is now calculating, or it is trying to predict certain features of this molecule. Okay, so as soon as I just scroll down, what it is doing, it has made prediction for the first molecule. So first molecule is this smile. Okay, so which is with which smile? It is talking about the first smile, which is this. Okay, which is the original amoxicillin. So for amoxicillin, the first thing that you can see is that, let me just zoom a little. Okay, so this is going to show you the property of this molecule, that how much polar it is, what is the size, it is falling into the range of druggability or not, what is the lipophilic feature of this molecule. So whenever the molecule is more polar, the lipophilicity will be probably less, how flexible the molecule is. So if your molecule is basically falling into this light red color zone, then the property of the molecule is considered to be good. That is the first thing that we can see over here. Then you just go over here and you check the physiochemical properties. Okay, then the lipophilicity, all these are all the indices which predicts the property of this molecule. Okay, then on to the right hand side, it shows the water solubility, so how water soluble it is. So just the uh, outcome, like it is very soluble. So these are the things that you can see. These are the values of log S. Okay, which will predict how the molecule is water soluble, how it can diffuse into your system. Then comes the pharmacokinetics. Now it says how well it will absorb into the gut. So it has a very low absorption, so this is something which is not good. So like this way you can understand what each and every property is trying to explain about the drug. Okay, then the next one is the drug likeliness. This is again very important. This is regarding what does the drug under study, or does the molecule under study has uh, or does it fit into the criteria of a good drug or not. Okay, so for that we use this parameter which called as drug likeliness. Okay, for that there are rules like Lipinski rule. So it follows the Lipinski rule of 5, and there are 0 violations, so it is considered to be very good. Okay, and apart from that there are other scores or other parameters where you can analyze. So then there is this bioavailability score as well. Then there is something which is also called as medicinal chemistry. Okay, now if you have any query and if you don't understand each and everything regarding all these parameters that have been shown over here, what you can simply do is that you can go to the small question mark that has been there around, or the small question mark which is just there beside the property. Okay, so as soon as you just put your cursor hover, or as soon as you just hover your cursor over it, it will show you what the property is trying to explain. Okay, or what that particular pharmacokinetic property of the drug means. Okay, so now this is about the original drug, and now let us compare it with the another molecule. So what it has happened is that this molecule was polar, and as we have changed the property of this molecule by changing the functional groups, what it has happened is that polarity has decreased. Okay, all the other parameters are falling into this red zone, so there is no problem over there. Okay, and if you just see, these are the another all the other parameters that we are interested in. Okay, so by changing the uh, structure of the drug, nothing much has changed, but as you can see, it has stayed soluble. GI absorption has remained low, so there is no change over here. It is not a inhibitor of this cytochrome P450s, which are the crucial cytochrome P450s. Um, and again, by changing this molecule, drug likeliness, and it follows all the rules of Lipinski. So there are no major changes that has happened regarding the toxicity or the pharmacokinetics property of this drug. Okay, but this does not always mean that the drug that you have created is good. Okay, this is why I'm telling, is because once you have changed the overall structure of the drug, that drug might not retain its uh, bioactivity. So for that, what you need to do is you have to perform molecular docking, and then you have to validate the results using molecular simulation dynamics. So this is another facet of the entire study that you are doing: molecular docking, and then checking the viability of that prediction that have been made by docking through molecular simulation dynamics is one part. You might get very good results over here, but at the same time, it may happen that your drug may not show good ADME scores. Okay, so for a drug to be very good, it should first of all be showing very good docking scores. It should satisfy all the requirements of molecular simulation dynamics, and then it should also satisfy all the SwissADME properties or ADME properties. Okay, so this is the basic understanding regarding this tool. Another tool that we will be studying, or I will be explaining in this tutorial, is called as a ProTox-II. So I will just click over it, ProTox-II. Okay, so again, it says, welcome to ProTox-II, a virtual lab for the prediction of toxicities of small molecules. So this is more pertaining to the toxicity, whereas SwissADME was more pertaining towards the pharmacokinetics and physiochemical properties of the drug. Okay, as well as drug likeliness. Whereas ProTox-II will provide you information regarding how toxic the molecule can be for your body. For that, what you do is you go to this web page. The link will be given in the description. And once you open this page, you go to this option which says tox production prediction. Sorry, so tox prediction is the button that we are interested in. So you simply click over it, and you come across this page. Okay, so what you do is here you can only add one molecule at a time. So we will just copy the single molecule. So we will just copy amoxicillin over here, and then you can paste it as over here. So I will just paste it as smiles. Okay, or okay, so once you've pasted your smiles, what you want to study, you check it over here. So it will provide you options like whether you want to check organ toxicity with the help of hepatotoxicity, that is liver toxicity. Does it have any kind of carcinogenicity, immunotoxicity, mutagenesis ability? Does a compound have or not? Does it have any kind of cytotoxicity? Okay. Um, does it bind to different kinds of nuclear receptor signaling pathways, proteins of different nuclear signaling pathways or not? Okay. Stress response pathways, does it induce any kind of stress response or not? So if you want to check all these properties, it is possible with the help of this tool which is called as tox prediction. Okay, so or ProTox-II. So over here what we will do is we will select all, and then we can press on this button which says start tox production. So it will take a while. The information will be fetched by its server. Now it will do its own calculation. It can take up to few seconds. Okay, and once the calculation is done, a page like this will open. So first of all, it will predict the LD50 dosage. So this is again very important if you are trying to replicate this study with the mice model or any kind of animal model. So this is the very good point to start your studies. Why? Because it will provide information regarding the LD50. Okay. Then as you scroll down, uh, as you can see, the most of the things are being calculated over here. Okay. So we will wait for few seconds as it is saying the toxicity radar chart. So it is trying to it is doing its own calculation. So we'll wait for a while. Okay. Very nice. So now the result have appeared on our screen. And as you can see onto the screen, what it is saying is that hepatotoxicity is slightly active. Okay, so probability is close to 0.7. So if you consume this drug for a very long time, then it is a high probability that it will damage your liver. So that is one thing. It says immunotoxicity, and it is saying active. It is close to 0.9. So it is this drug can be uh, immunotoxic, means it can induce allergic reactions to the body. It can activate immune system in the very different way. Okay. It is not having any mutagenicity, so that is a good thing. So it is not showing also cytotoxicity. Okay. Then if you just see, it is interacting with the aromatase receptor, or it can also interact with the estrogen receptor. So these are all the active things. So for any drug to be a very good drug, in short, I want to tell that all this has to be in green color. Okay, so more the green color, better for the drug. So that is something that we have to understand. Okay, now this is the toxicity chart. This is again a very nice chart. So if you just click over it, it will show you the entire radar. Okay, so so basically what is happening is that you have to look at the blue points. Okay, so for most of the things, if you just scroll out a little. Okay, so for most of the things, if your drugs falls within this orange, the if the blue spots falls within this orange part, then it is considered to be good. And if it falls apart, or if it goes over this boundary, it is called as it is the alarming issue with the drug. So this is something that you can study regarding this drug as well. So these are all the different parameters regarding the drug, and what is the probability is been mentioned over here. Okay, so everywhere over here. Okay, so if your parameters fall within this orange area, then over here the properties will all be in the green, but all those which are falling outside that orange area are mentioned over here in the red color. Okay, so that is something that we can take in for an account. Now what else we can do is that there is another tool that we are interested in. Okay, so the another tool is called as admetSAR. Okay, so we'll go over it. So this is admetSAR. Okay, so this is the updated version of this tool, and it says that welcome to admetSAR, a comprehensive source and free tool for evaluating chemical admet properties. admetSAR is free for non-commercial use only. For any query, please contact us. Okay, so what you do is you simply paste the smiles. So we have already copied the smiles of amoxicillin, so you simply paste it over here. Okay, and you simply click on predict. Okay, so as soon as you click on predict, what happens is that it will give you this link. Okay, so you click on this link, a new page will open. This page you have to keep refreshing it after every 5 to 10 seconds till your results appear over here. If you lose this link, then you have to repeat the entire process again. So we will wait for few seconds. I will refresh this page again. Okay, so it is computing. So if you just see, it has computed few properties regarding this drug. So starting with the molecular weight, log p value, how many hydrogen bond acceptors are there, how many hydrogen bond donors are there, how many rotatable bonds are there in this molecule. Okay, then different kinds of admet properties are shown over here. Now you can read about each of these in detail one by one, but the easiest way to or the most convenient way to study this is that you have to look in for something which is in the red color. So if you just see human oral bioavailability, it is showing in red color. So that is unwanted property, or that property of the drug is not good. You just scroll down. Okay, Then there are some properties in red color. So carcinogenicity, here it is saying binary. Okay, so very little. So still it is in red. So we have to be careful with this drug. Okay, all these are in green, so it is good. Okay, so wherever there is an issue with any kind of interaction happening in our body which is harmful for us, there will be a plus symbol over here. Okay, plus symbol. So wherever there are plus symbol, okay, those are the problematic, those are the things which can be interacting with this drug and creating the problem. Okay, so hepatotoxicity, there is a very high chance in this tool as well. Okay, so you have to look for this plus sign and the minus signs and the different number that you can see. Okay, so most of this are in the green color font, so it is okay. Then over here, if you just see fish aquatic toxicity, it is saying plus, so it is toxic to fishes. So all these things you can do with the tools that I have explained over here. So let me go back. So till now I have explained these three tools: SwissADME, ProTox-II, admetSAR. Okay, SwissADME will allow you to add multiple entries. So it will do its calculation simultaneously, whereas in ProTox-II and for admetSAR, you have to input your ligand smile strings one after the another. So this is all about this three very important ADMET tools. Now over here, I also want to talk about the tool which says SwissTargetPrediction. So SwissTargetPrediction is another tool by Swiss or SIB, Swiss Institute of Bioinformatics. Okay. Now what it does is that uh, this is a tool which will allow any small molecules, okay, to be checked for its property to interact with human proteins or not. Okay, so here there are it will predict out of 3,70,000 known active molecules is evaluated with this Swiss target, and there are more than 3,000 proteins from three different species will be screened for the molecule which you use here for the input. Okay, so if I put the smiles of amoxicillin over here, okay, first of all, it will draw the structure of that amoxicillin. This window is again taken directly from Marvin Sketch, so you can use all those things which are there on the Marvin Sketch online. So you can also modify the structure over here and then predict the targets. Now, as soon as I have pasted my smile over here, and if as soon as I press on the predict targets, what it will do, it will fetch the proteins out of this 3,000 which has propensity or probability to interact with the drug. Okay, so let us see that out of this 3,000 proteins, amoxicillin has ability to interact with which proteins of human body. So we are selecting Homo sapiens over here and we will press on predict targets. So job is running right now, and then it is saying your job is running currently. So we'll wait. We need to wait for a few seconds, and then as you scroll down, it says that there are very few probability for this drug to interact with the proteins of human body. Okay, so lesser the or shorter the green bar, it is lesser the probability of the drug to interact with the protein mentioned over here. Okay, so as you just go on to the next page and then next page, next page, next page, next page. So with all this proteins of human body, the probability of this drug to interact is very less. So that is a good thing in a way. Okay, why? Because this drug is basically designed to interact with bacteria, not humans. Okay, amoxicillin will interact with bacteria and it will kill the bacteria. So therefore, it should not interact with human protein. So that is a good thing. But if you are designing a drug which can specifically interact with the key targets of human body, okay, then this tool can be of a great help. Okay, so till now I have explained the tools like SwissADME, ProTox-II, admetSAR, and Swiss Target Production, and all these four tools are very much useful for the studies where you are designing new drug, or you are doing or if you are doing natural product chemistry, or if you are creating the derivatives, or if you are working with the phytochemicals, or if you are working with the derivatives of phytochemicals. So these tools will help you to predict how this molecule that you are trying to develop, how will it interact with the human body, will it show any kind of toxicity or not, or does it have any propensity to interact with different proteins of human body or not. Okay, so I hope this is an important video for you, and it has, or it may have provided some information that you are looking for. So stay tuned to my channel. I will be bringing up such kind of videos for your information. But when you're working with these all molecules, you need to remember that this is the second facet of your study. The first thing, when you are designing a new drug, you have to perform molecular docking with the target protein, check whether the predictions that are made by molecular docking are satisfied with molecular simulation dynamics or not. Okay, and once you get all those results correct, then you come over here, check the drug like properties and pharmacokinetic properties, pharmacological properties, toxicity properties of the drug. And then when once everything is satisfied, that drug can be taken forward for the testing at the laboratory scale with the animal models. Okay, so I hope this video is helpful to you. Stay tuned to my channel. You can like and subscribe to my channel. So yeah, thank you.